Hello, all my dear students. Welcome to Sri Jain's Rank Zone classes. My name is Ajay Gulati, and I'm your friend and mentor for the mathematics portion that is we also call as quantitative aptitude. Dear students, as you can see on your screen, we'll be discussing the chapter permutations and combinations today. So, dear students, let's start with class 01 for permutations and combinations. Okay, dear students, how will we proceed with this? See, before I do anything, one thing I need to tell you is factorial, the concept of factorial. Okay, what is factorial? See, factorial is generally said to be like if I say 5 factorial, it means the sum of all the natural numbers starting from 1 up to 5. 5 into 4 into 3 into 2 into 1. 7 factorial will be sum of product. I did I say sum? It is actually product. 7, 6, 5, 4, 3, 2, 1. Or this can further be written like 7 into 6 into 5 factorial. I am replacing this by 5 factorial. This is the meaning of the word factorial. Okay. This is the meaning of the word factorial. And the conceptual usage I will tell you in a short while. Before that thing, okay, dear students, before that thing, what I just need to tell you is I need to tell you two basic fundas: addition principle and mathematics and multiplication principle. Okay, see, let's say multiplication principle. When do we apply multiplication principle? Multiplication principle is applied when we have when it becomes necessary to do something. See, let's say I need to get ready for a party. Okay, I wish to go to a party. To go to a party. Okay, to a function, anything. And I have, let's say, and I have some clothes with me. I have, and I have five shirts, four shoes, and three trousers. And three trousers. This is one thing. Then comes addition principle. I will explain both of them to you. Addition principle is, let's say, my wife. Okay, she needs to get ready. She needs to go to a party. Okay, let's say she has four gowns with her. Okay, so how many choice does she have? She can wear any one, two, three, any one of the four gowns. She has four choices. Okay, why? See, you can take any one of the four gowns. Your work is done, over. But when it comes to me, I'll have to apply multiplication principle. Why? Wearing a shirt alone won't get me ready. I'll have to get a shoe also. I will get have to get a trouser also. So there, here we will apply a multiplication principle. Out of the five shirts, I have five choices. Out of the four shoes, I have four choices. Out of the three trousers, I have three choices. Combined together, how many choices do I have? Combined together, I have 5 into 4 into 3 choices. That is 120 choices. Getting it, dear students? Very clear to all? Okay, confirm? Fine. Let me take one or two more examples. Addition principle, multiplication principles. Suppose I say I need to go from A to B. I need to go from A to B. Let's say there are two choices, two paths which I can follow while going from A to B on bike. For car, I have three choices. For car, I have three choices. 1, 2, 3. So this is addition principle right now. This is addition principle. Okay. These are bike and these are car choices. So how many ways can I go? How many ways can I go from A to B? I can go from A to B in these are two paths, these are three paths. 2 plus 3, that is 5 choices. Okay, clear. Next, I say I need to go from A to B and B to C. But A to B, I can go by bike only. From B to C, I can take car only. Okay. And from A to B, I have two paths. Okay. And going from B to C, I have three paths for my three different paths for car. So how many ways? Here it was addition principle, here it is multiplication principle. Multiplication principle is applied when the task is not completed. If it's only A to B, then there are two choices, 1 plus 1, this is the addition principle. If there was only B to C, then there was 1 plus 1 plus 1, three choices, that was also addition principle. But when it comes to A to C, I will have to cover B. A to B, there is one task. Okay, when that is completed, then I'll follow the task B to C. So I will have to multiply both of these. So this is A to C. There are how many ways? 2 into 3, that is 6 ways. Is this part clear to everyone? Confirm? To explain this concept to you in more detail, I can take a one more good example. This was multiplication addition principle. Let's say one of my friend comes to me, or forget about a friend. Now suppose I plan to donate one clothes. Suppose I plan to, let's say, gift. I plan to gift piece of cloth, one piece of clothing, okay, to my brother. Then how many choices do I have? Then how many choices do I have? How many choices do I have? Now I have, dear students, either I can give him 5 shirts, or I can give him one out of 4 shoes, or I can give him one out of three trousers. Okay, so how many choices do I have? I have 5 plus 4. I just need to give one. I can take one from these. If I won't take from this, then I will take from this. If I won't take from this, I will take from this. But out of these, I will have to take at least one. So I have 12 choices. This is the basic thing. Okay, dear students, clear to all. Next one. This thing is, I hope, clear to everyone. Now, let me take an example for you. Let's say I am a director. I need to make a movie. I'm a producer, suppose. Okay. I need to make a multi-star movie. Now I'll be starting with the concept of factorial. Okay. I'm a producer, and I need to make a multi-starrer movie. When I need to make a multi-starrer movie, what I will do, what I'll say is, see, 5 heroes, 5 heroines, 5 actors, 5 actresses. Let's say the heroes are SRK, SK, Amir Khan, Hrithik Roshan, and let's say Tiger Shroff or Akshay Kumar. Okay. The 5 heroines are, let's say, Deepika, let's say Katrina, Karina, mm, then we have Alia, and then we have Anushka. Okay. Now, in how many ways can I cast them in pairs? In how many ways Can I cast them in pairs? Okay. Can I cast them in pairs? What happens? See, for the first place, let's say first I have SRK. Okay. Let's say first I have fine SRK. When first I have SRK, SRK has how many choices? He can pick any one of the five movies. Director give the producer, I allow him to choose any one heroine in opposite to him. He picks any one out of these, so he has five choices. Then my work is not over. I have to multiply. Then I come to Salman Khan. Sallu bhai, you have four choices. He SRK has reserved Alia for her. Now you can take any of these four. So he has four choices. Then I come to Amir Khan. I come to Amir and tell he has taken Ali and Anushka both have been occupied, have been booked. Now it come you can pick any three, one out of any three from Deepika, Katrina, Karina. He will pick one. Like this, there'll be two, then this one. This is the concept of factorial. When you have to distribute equal things in equal number of people so that everyone gets one each. I again say when I have to arrange things like each person get exactly one thing, then how and there are n person and n things. Then we apply this logic. This is the number of ways is 5 factorial. Okay, this is the concept. I hope you have got it. Now, in same situation, suppose I say Katrina refuses to work with SK Salman Khan. Then what will happen? See, then we have SK has four choices. Okay, got it? Salman Khan has four choices. Why? Because the option of Katrina is not available to him. So he will pick one out of Deepika, Karina, Alia, Anushka, anything like this. Now it comes to SRK. We will put that fellow first who has a limited number of choices. Okay. SRK has out of the remaining four heroines, he can pick anyone. Amir Khan can pick out of the remaining three, he will pick anyone. Then Ritik Roshan out of the remaining two, he will pick one. Finally, Akshay Kumar will pick anyone out of. So this is 4 into 4 factorial. This is called 4 into 24 or 96. 5 factorial. The value of 5 factorial is 120. I hope so far this basic concept is clear to everyone. Okay. Now let's proceed further. This was one basic concept which we have done. I hope this far you are in rhythm with me. I'll take a similar concept for you. The number of ways in which five different people can be seated in five chairs. The number of ways in which I can arrange five people on five chairs. In which I can seat five people on five chairs. Let's say these are the five chairs. One, two, three, four, five. C1, C2, C3, C4, C5. Okay. Or I can say, let's say these are the persons P1, P2, P3, P4, P5. For this first person, how many choices do I have? He goes in a room, he finds five chairs. He goes in a waiting room, he finds five chairs. He'll sit on any one of those. So he has five choices. The next fellow when comes, he sees that one chair has been occupied. The remaining four chairs are empty for him. He can choose any one of those four. So he has four choices. The next fellow comes, he finds that two people are already sitting. There are three more chairs, so he will pick any one out of three into two into one. So this will give you 5 factorial. Is this thing clear to everyone? I am sure it must be clear to all of you. Okay, dear students, should I move ahead? Fine, let's take the next one. This thing I've done already. Now, dear students, that comes the concept of combinations. Okay, combination. Nations, the concept of combinations. Okay, fine. Before I come to this question, let me show you an easy example. See, I have 5 pens. In how many ways can I pick one? In how many ways can I pick one? Obviously, I have 5 choices. 5 choices. This is called 5C1, 5 out of 1. And what is 5C1, dear students? What is NCR? NCR is actually n factorial divided by r factorial divided by n minus r factorial. N factorial divided by r factorial divided by n minus r factorial. Here I will show you. Here 5C1 will be what? See, if you have to pick one thing out of 5, how many choices do you have? One, 2, 3, 4, 5. Either you will pick this one choice, this. So you have 5 choices. Okay, you have 5 choices. So 5C1 will be 5 choices. This is like this. And if I apply the formula, by application of formula, it will be 5 factorial into 1 factorial into 5 minus 1 factorial. That is 5 factorial into 1 factorial into 4 factorial. 1 factorial is 1. That will be what? 5 into 4 factorial divided by 1 into 4 factorial. So finally, this is 5 choices. Clear to all? Now NCR is equal to n factorial r factorial n minus r factorial. This is the way I have used it in front of you. Fine. Suppose I say, suppose I have, suppose I have 4 fruits, but only 2 pockets to carry them. But 2 pockets to carry them. Okay. Then, then in how many ways can I put 2 fruits in my 2 pockets? Put 2 fruits in my 2 pockets. In my 2 pockets. See, it will be, now I will show you the concept in detail also, by counting also, by formula also. Okay. See, now what will happen is, see, let's say the 4 fruits. Suppose 4 fruits are apple, orange, kiwi, and let's say banana. So what are the possible combinations for me? Either I pick a, first suppose I pick A, then I can take a AO, I can take a AK, then I can take a AB. Okay, let's come to orange. Now, all the possible options with apple have been consumed. Now let's come to orange. With O, I can take a kiwi, or with O, I can take a banana. Okay, with orange, I have a kiwi, I have a banana. And finally, with kiwi, I have only one choice, banana. Why? Because kiwi has been consumed with all the others, included with all the others. So, how many choices do I have? 6 choices. This is mathematical. This is by counting logically, by formula. Okay, by formula, it will be, I need to pick 2 out of 4. In how many ways can I select 2 combinations out of 4? That will be 4C2. Let's find the value of 4C2. I'll be very slow towards doing this. 4 factorial divided by 2 factorial, and this is 4 minus 2 factorial. This is the number of selecting number of ways. So this becomes 4 factorial divided by 2 factorial into 2 factorial. That will be what? 4 into 3 into 2 into 1 divided by 2 factorial is 2 into 1 into 2 into 1. 2 and 2 cancel, 2 and 4 cancel will give you a 2. So this is 2 into 3, 6 choices. Okay, clear to all? NCR is number of ways of ways of choosing choosing are things out of and distinct things. That is NCR. NCR is NCR. The value for NCR is n factorial by r factorial into n minus r factorial. Similarly, now we come to a very important and interesting concept, that is number of handshakes. Number of handshakes. Okay. So the number of handshakes is like, see, let's say we have five people in a group. Five people in a group. Let's say A, B, C, D, E. Then how many handshakes are possible? See, A will shake hand with how many people? B, C, D, E. Four options. Four options. B will shake hand with how many people? C, D, E. We have three options. C will shake hand with how many people? D and E. He has two options. D will shake hand with only one people. Why? Because he has already shaken hand with previous people. B will now not shake hand with A because A and B have already shaken hands. This is one. Okay. So total handshakes is how much? Total handshakes is how much? Total handshakes is 4 plus 3 plus 2 plus 1. See, this is actually 5C2. Find your students. 5C2. How come? 5C2 is how come? You have to pick, here I write, you have to select any two people out of five for a handshake. So therefore number of ways is equal to 5C2. Therefore number of ways is equal to 5C2. This is the concept. Okay. 10 people in a room. See, whenever it is like the summation 4 is 5C2. Okay. If I write 1 plus 2 plus 3 plus 4 plus 5 up to n, so it will be n plus 1 C2. Or if I write up to n minus 1, that will be n C2. N C2 is what? 1 plus 2 plus 3 plus 4 plus 5 up to n minus 1, that will be n C2. Okay. So 10 people, how many handshakes? 10 people in a room, then how many handshakes? How many handshakes? That will be 10 C2, or I can say summation 9, or 1 plus 2 plus 3 up to 9, that is 45 handshakes. This part is done. Just select any two people, out of 10, that will give you number of handshakes. Okay. The moment you select two people, you get a handshake. So how many times you can select two people out of 10 people? That is 10C2. 10C2. I hope this concept is clear to everyone. I'm just looking how much space do I have. I have very limited space. I need to add one more page, no problem. Before coming to the next point, let me elaborate the process of NCR, the thing NCR. See, whenever you have na NC2 is actually what? Summation n minus 1, or this is n into n minus 1 by 2. Fine. The moment I say 15C2, what I'll do, it will be 15 into 14 by 2, that is 15 into 7, it is 105, or it is summation 14. This is actually what this is actually summation 14, that is summation 14, or 1 plus 2 plus 3 up to 14. So summation 14 is like this. Clear, dear students? Suppose I say 20C2 or 21C2. 21C2 will be what? That will be summation 20. Summation 20, or 20 into 21 by 2, that is 210. This part is clear to everyone? Okay. Few summations you must be thorough, dear friends, so that you can save time in your exam. Summation 2 is what? 3. 1 plus 2, 3. Okay. Summation 3 is 1 plus 2 plus 3. This is 6. This is 4. C2. 5. C2 is summation 4. That is 10. 1 plus 2 plus 3 plus 4. 6. C2 is summation 5. That is equal to 15. 7. C2 is summation 621. 8C2 is summation 7, that is 28. 9C2 is summation 8, that is 36. 10C2 is summation 9, 45. Last 11C2, this is important. This is summation 10 or 55. These are the few values which you must be thorough with. Okay. Then the next thing is, you have, suppose I write NC3, how will you calculate this value? Or if I write, suppose 663, or I write 7, 8, C5, how will you solve this? See, the moment you I write 8C3, what you will do, 6C3, you will take 6, as I have told you the NCR minus formula, but better way is, it is 6C3, 6 into 5 into 4 divided by 3 into 2 into 1. From here, 3 numbers in descending order, 3 to 1. From here also, 3 numbers in descending order. Okay, 3 into 2, 6, cancel, this give you 28C5, you can also write as 8C3. 8C5 is equal to 8C3. See, this thing you have to keep in mind, dear students. The thing is important. NCR is equal to NCN minus R. I will explain it to you. How come NCR is equal to NCN minus R? Just think about, dear students. When I ask you to pick 4 things out of 10 things, what you will do, you will pick a group of 4. The moment you pick a group of 4, a group of 6 is left on the other side. Okay, so the number of times you pick 5 is equal to the number of times you are keeping 6 things aside. So 10 out of 4 will be 4. Selecting 4 out of 10 is equal as selecting 6 out of 10. This thing you need to remember. NCR is equal to NCN minus R is equal to, or is equal to n factorial upon R factorial into R minus factorial, n minus R factorial. These are the same things. Okay, if I say 12C3 will be equal to 12C9. Whenever I say 18C5, that will be equal to 18C13. Right now we have 8C5. I will write this as, see, this number is bigger. I will put a smaller number over here. 8C5 will be equal to 8C3, and that will be equal to 8 into 7 into 6 divided by 3 into 2 into 1. This cancel. This will give you what? 8 into 7, 56. Am I very clear to all of you? Okay, dear students. Just give me a small second. Let me recheck. Fine. This thing I have told you, 5C1 is 5C4 equal. But still, I'll tell you this thing again in detail, no problems. So far, I think everything is clear to everyone. Let me take one more example. Suppose I say 10C3. 10C3 will be equal to 10C7. That will be what? That will be 10 into 9 into 8 divided by 3, 10C3. In fact, I should write 10C7. Somebody asked me. I will find 10C3. Okay, that will be 10C3 is equal to 3 into 2 into 1. 3 and 9 cancel to give me a 3, or I can directly say this is 720 by 6 to give you 120. I hope so far things are clear. If somebody says 15C13, I won't find 15C13, I will find 15C2. 15C2 is actually what? Summation 14, that is 210, or it will be like 15 into 14, sorry, 15 into 14, summation 14 is 14 into 15 by 2, or directly two numbers from here, two numbers from here, 2 into 1, that will give you 105. Am I clear? Suppose somebody says 20C16, what I need to find is 20C4. These will be same, and it will be like 20 into 19 into 18 into 17 divided by 4 into 3 into 2 into 1. So 3 into 2 is 6. This will give you a 3. This is 5. So 5 into 3 is 15 into 17 into 19, or 15 into 3 to 3. Clear? Can you multiply this? I am leaving it to you. Otherwise, you can multiply it like this. 15 into 3 is 4500. 15 into 20 is 300. 15 into 3 is 45. You can add this 4845. This will be the answer. I hope you are connecting with me, dear students. Now the next thing is number of line segments out of n non-collinear points. Out of n non-collinear points, that will be equal to nc2. See, you have n points. None of them are, no three of them are collinear. Okay, no three of them are the straight line. Out of n non-collinear points, you just pick any 2 points, you will get a line segment. Simple. The logic is just pick any 2 points, you will get a line segment. Okay, so number of lines that can be formed from 7 points is equal to 7 C2, or summation 6. What is summation 6? Summation 6 is 21. Okay, dear students, summation 6 is 21. This portion is NC2. If it might not be have been visible, I am just marking this. This is NC2. I'm sure this is visible now. I'm not sure while I was writing where it was at beneath, the bottom or top, where this thing you have got 12 points, 12 non-collinear points. Okay, how many line segments? So we have, this will be equal to 12 C2, or summation 11, or 66. Clear to everyone? Fine. Now I come to a very good concept. N-sided polygon. N-sided polygon. How many diagonals? We have a n-sided polygon. How many diagonals are possible? How many diagonals are possible? That will be nc2 minus n, or that is n minus 3 by 2. I will explain to you why. How? See, we have n points. We have n points. So total line segments Total line segments will be NC2. Okay, will be NC2. Out of these NC2 lines, out of these NC2 lines, outer N lines, outer N lines will form the polygon. Outer N lines will form the polygon, will form the polygon. Therefore, remaining NC2 minus N will be the diagonals. Will be the diagonals. Remaining NC2 N minus N will be the diagonals. Clear? Remaining NC2 minus N, or this can be said to as N. What is NC2? N minus 1 by 2 minus N. This will be what? This will be N into N minus 1 minus 2N by 2. If I take N common, what I will be left is N minus 1 minus 2 by 2, or N into N minus 3 by 2. Clear? Let's take one example based on this. I will further show it and then I will do example. Suppose I have 6 points. I take any 6 points like this, okay? One, two, three. I'm myself taking a hexagon. Obviously, it will be a hexagon. I join these 6 points every possible way. Let's start with this point. I join it to this. 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 So far, how many? First, I am the first point I'm selecting. I'm joining with 5 points. Let's start with this point. This is the second point. I join this with 1, 2, 3, 4. 5 plus 4. Okay, 6 points is 6 C2 lines. You know that thing. Huh? This is what I'm proving in front of you is equal to summation 5. And then I start with this 1, 2, 3. I write 3. Then I move to this 1, 2. I put that 2. Then last one I can join only this 2 plus 1. Total how many? 6 points will give me summation 6 minus 1 lines. Summation 6 minus 1 means summation 5 lines, or 6 C2 lines, or let me write 6 C2 lines or summation 5 lines. Fine. Now what I say, out of these 6 C2 lines, 1, 2, 3, 4, 5, and 6. Outer 6 lines form the polygon. Form the polygon. Therefore, 6C2 minus 6 will be the inner diagonals. Will be the inner, inner spelling I have written wrong. Inner diagonals. Okay. 6C2 will be summation 5, that is 15. 15 minus 6, or 9 diagonals. You can count them, or 9 diagonals. So far, I hope everything is clear to everyone. Okay, dear students, 9 diagonals. I'll take one previous year question from this. Just give me a small second. In a polygon, the number of diagonals is 54. The number of sides of the polygon is C. N is the let n is the number of sides. Okay, n is the number of sides, is the number of points or sides. Okay, then number of diagonals is what? N into n minus 3 by 2. I've just proved it to you a few minutes back, 54. So n into n minus 3 is equal to 54 into 2. Either you can solve it or you can interpret it like this, the way I'm doing. That will be what? You can say this is 12, this is 9 is equal to 108. So n is equal to 12. I hope all this is clear to everyone. Okay. Now we come to a very important aspect, a very important concept, that is number of triangles possible. Number of triangles possible. If we have n collinear points, if we have n collinear points, okay, then how many triangles can be formed? Then we can form n non-collinear points. Okay, non-collinear means those which are not in line. If we have n non-collinear points, then we can form NC3 triangles from those, from these endpoints. If we have, if we have, if we have, I say, n points, if we have n points, then we can form NC3 triangles from these n points, from these n points. If no three of the points, if no three of the points are collinear, means no 3 points are in straight line, then we can form N3, NC3. Okay, no three of the points are collinear. It is like how many triangles, how many triangles I form, can I form from 12 points if none of the 3 points are collinear, if none of the 3 points are collinear. We have total 12 points if none of the 3 points from those are collinear. So we have the direct formula for this, that is 12C3. Okay, dear students, let's take a few questions now. Just the main thing. Now I say, if out of these n points, let's say if out of these n points, m points are collinear, m points are collinear, then how many triangles can I form? Then number of triangles that can be formed is, the number of triangles that can be formed, see, n points, I repeat again this thing, n points can form NC3 triangles. Why? You have to just pick out, you have to select 3 points. The moment you select 3 points, you join them, you get a triangle. So whenever you need to make a triangle, what you do, you will join just 3 points out of n points. You will pick 3 points out of n points, you will get a triangle. That is, picking 3 points out of n points. Picking 3 points out of n points will give you a triangle. Got it, dear students? So number of triangles that can be formed is NC3. But if m points are collinear, so those m points, had they not been collinear, they would have formed MC3 triangles. But now they cannot form even a single triangle. So this is NC3 minus MC3. This is your concept. Okay, NC3 minus MC3. Now on the basis of this, so 10C3 is like 10 into 9 into 8 divided by 3 into 2 into 1. NC3 is n minus 1, n minus 2 into 3 into 2 into 1 is equal to 66, is equal to 110. 110. So that is 10 into 9 into 8. 9 into 8, 72 into 10, 720 minus n minus 1, n minus 2 is equal to 6 into this is 660. So now what I get? I get 720 minus n minus 1, n minus 2. 720 minus n minus 1, n minus 2 is equal to, I'm sorry, I need to write this here. Minus 660 is equal to n minus 1, n minus 2. Now think about it, dear friend. This is 60 n minus 1. These are three numbers in descending order. If I write, they are multiplied. Can I say 5 into 4 into 3? Clearly, n is equal to 5. I hope this portion is clear to everyone. Now we have a question. How many ways, how many combination of four letters can be made out of the letters of the word Sachin? See, dear students, I thought I don't have space in this. That's why I was writing in such a limited space. Okay, so it's actually now we have enough space. How many combinations of four letters can be made out of the letters of the word Sachin? See, Sachin has how many characters? Six characters. Okay. Select how many characters? Select four characters. So it means n is equal to 6 and r is equal to 4. So 4 out of, select 4 out of n. Select 4 out of 6, that is 6c. 4, that will be 6 factorial into 4 factorial into 2 factorial. From next time onwards, what you will do, you will directly do the upper two numbers and the lower two numbers. If it is 6c3, the upper three numbers into lower three numbers, like this. You can see it 6 into 5 into 4 factorial divided by 4 factorial into 2 into 1. So 4 factorial and 4 factorial will cancel. 30 by 2 is equal to 15. Clear? I hope this is clear. Now I say how many. Let me directly find a question for you. Just give me a second. The next question is how many ways can I call 3 friends out of my 10 friends for a dinner at home? N is equal to 10, R is equal to 3. We need to find NCR, that is 10C3. And how will you calculate? It will be directly 3 larger numbers. From 10, I'll take 3 larger numbers, and here I'll take 3 smaller numbers. Okay. So that will be like 10 into 3 into 4. 3 and 9 will cancel to give you a 3. 2 and 8 will cancel to give you a 4. That is 120 ways. Confirm it is clear to everyone. Okay. Let's take the next one. The next question we have is in how many triangles can be formed drawn from 12 points on a circle. See, you have 12 points. Here n is equal to 12, and you, in order to draw a triangle means 3 points. So is equal to r is equal to 3, r is equal to 3. How can you draw a triangle? You just have to pick 3 points. You pick any 3 points, you connect them, you will get a one triangle. You will get one triangle, okay? So what we require? We require NCR, that is 12C3, or 12 into 11 into 10 Three numbers from larger to smaller and three smaller numbers like 1, 2, 3. 2 into 3 is 6. So this is 2. 22 into 10, 222 ways. I am sure this concept must be clear to all of you so far. And you must be enjoying this, okay? Let's take the next one. Now let's take few more conceptual questions which you will be able to solve directly. The question is, in how many ways can six boys and six girls be made to sit in a row having 12 chairs? See, there are no limitations. There are no limitations, no constraints. Okay, what we are told, number of people, number of people, 12. Number of chairs, again 12. So number of ways of seating them, which I have discussed earlier, number of ways of seating 12 people on 12 chairs is equal to 12 factorial. This is your answer. Clear to all? Yes, it must be clear. Let's take the next one. In how many ways can six boys and six girls be made to sit in a row having 12 chairs so that all the girls sit together? See, dear friends, we have all the girls sit together. Let's say we have 12 chairs. Assume just out of those 12 chairs, 6 chairs are combined. 6 chairs are combined in such a way that only 6 girls will sit on those chairs. Okay. So, first, I say put combine 6 girls, they become one entity now. Okay, combine these 6 girls, these become one entity. One entity now. In how many ways can 6 boys and 6 girls be made to sit in a row having 12 chairs so that all the girls sit together? Okay, dear students. 6 girls I combine. And how many? And what do I have? I have 6 single boys. 6 girls are one entity. And I have like B1, B2, okay, B3, B4, B5, and B6, sixth boy. That is now I have to arrange these 7 people. These are 1, 2, 3, 4, 5, 6, 7. I have to arrange these 7 people. In how many ways can I arrange these 7 people? In 7 factorial ways. Getting it? 7 people on 7 chairs. Out of those 7 chairs, one chair is a very big one, which is like 6-seater in itself. 6 girls can sit on it. Okay, so you have 7 factorial. But now comes the most important thing, which you should not miss out. These 6 girls are sitting in a row in 6 chairs. Okay, these 6 girls can be arranged among themselves in 6 factorial ways. So this is 6 factorial into 7 factorial. This is your answer. Does it make sense? 6 factorial into 7 factorial. This is your answer, dear students. Next question. Now we have number of ways in which 7 girls and 7 boys can be seated on a. Now the next thing is, which comes in line with this previous question, is in how many ways can 6 boys and 6 girls be made to sit in a row having 12 chairs so that all the girls don't sit together. All the girls don't sit together. See, how will I do it? The thing is, dear students, all the girls should not sit together. See, total ways, if from total ways I subtract when girls are together, when 6 girls are together, when 6 girls are together, what do I get? 6 girls not together. This will give me all girls not together. That is 12 factorial minus this 7 factorial into 6 factorial. This is your answer. Fine. Clear to all? Let's take the next one. This is a very good question, conceptual question now. In how many ways can six boys and six girls be made to sit in a row having 12 chairs so that no two girls sit together and no two boys sit together? See, no two girls sit together, no two boys sit together. What do? I do it like this. B1, I leave a space. B2, B3, B4, B5, and B6. Okay. Now, what do I have? I have six places, six benches in which I can place seat six boys. So this will give me six factorial ways. Okay. Now, the next thing. Now I have to seat seven girls. Think about it, dear friends. I have to seat seven girls. In how many ways can I seat these seven girls? Six girls. Okay, so that they no two boys and no two girls sit together. See, if no two boys and no two girls sit together means I will have to arrange one girl over here, here, anywhere. Matlab in between these five places. Okay, but one more very important thing is, see, I have seven spots. How come I can arrange a girl over here also? I can arrange a girl over here also. Getting this thing, dear students. Fine. So if out of these seven places, I repeat, these five places are necessarily filled by girls. Why? If girls sit in these five places, then no two boys will be together. Now there are two more places. Now there are two more places where I can place one girl. Either I can place the sixth girl over here, then it will be like one, two, three, four, five, six girls, or I can say I can place the sixth girl over here. Okay, so I have two choices for placing one girl either on the left hand or on the right hand. Now I have decided that these are my six places for girls. Okay, let's say one, two, three, four, five, six, and these six places I can place six girls in how many ways? Six factorial ways. This is one way. The other way, see, I have 12 chairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The thing is, I can place the boys at odd places, odd chairs, girls at even chairs. Or I can do the reverse. Boys at even chairs or the girls at odd chairs. This is the same thing which I've done earlier, but I'm explaining it to you in a different way. So this is how many ways? Two ways. Either I can pick this one or I can pick this one. Now there are six even places and six boys. Number of ways of arranging them, six factorial. Six odd places and six girls. Number of ways of arranging them, six factorial. So this gives you 2 into 6 factorial into 6 factorial. This is your answer, the same as the previous one. Super clear? Okay. So my dear students, today we have done almost every possible question pertaining to this exercise, and I hope if you practice these questions you will be easily able to master your topic permutation and combination. And the best thing about this permutation combination is the questions are might appear to be tough, but they are very small. You can solve them in very limited time, so make sure you practice them by writing, because it will take very little time to practice. And once you become a champion of these questions, you will be very easily able to solve these questions in your exam in very limited amount of time, which will give you more time to solve further questions. So with this, I will take your leave by saying, please practice as much as you can. Just by watching the videos, you won't be able to solve them in your exam. Practice as much as you can. Practice by writing. All the very best, dear students. Crack your exam. Bye bye. Take care.